Lesson 5.5, Performing Function Operations. Our essential question: how do you add, subtract, multiply, and divide functions? So today we're going to look about operations on functions. If we have the function f and the function g, they're allowed to be any two different type of functions. With those two, a new function can be defined by performing any of the four basic operations on f and g. Our basic operations were add, subtract, multiply, and divide. So our first operation that we're going to learn about is adding. I see that I want to add the function of f and g, and then be able to still take that to the x. If we're going to add the functions f and g, we need to individually find the f and the g and add them. So we have an example. It says that f of x is 5x, and g of x is x plus 2. We are being asked to add the function f with the function g still in relation to x. To do that, we're supposed to take the function f of x, and we are supposed to add it to the function g of x. To help us see that, we're supposed to take the function f, which is this function right here, which is 5x. So here is my 5x function from f of x. And I'm supposed to now add, so here's me adding. I am now going to add the entire function of g. The entire g function is going to go right here. What is the g function? The entire g function is x plus 2. So right here I'm going to write x plus 2. It is important to write the grouping symbol around the entire g of x, because this function is going to be added to the entire function. So what do I actually have? I have 5x being added to this x, being added to this positive 2. So now combining like terms, I have 5x plus x, which is a 6x, plus 2. This is my new f plus g function. Now something to remember, domains and ranges when you are developing a new function. The domains of the sum, difference, product, or quotient functions, so if we were to add, subtract, multiply, or divide to come up with a new function. The domain of that brand new function is going to consist of all of the x values that are in the domains of the both original f and the original g. The domain of the quotient, meaning when you were dividing, does not include the x values for when the g of x, which is the denominator, would end up being 0. Let's go ahead and do a practice problem. We're going to let f of x be the 3 times the square root of x. And we're going to let g of x equal negative 10 times the square root of x. We're being asked to find the f plus g of x and then state the domain. So I'm going to split my paper right down the middle. On this side, we're going to go ahead and add the two functions. So f plus g of x. If we're coming up with the new added function, you are supposed to add each function individually, which means that I need to find my f function, which is the function right here. So I'm going to have my f function, which is 3 times the square root of x. I'm supposed to add now my g function, which is this function right here. So I'm going to add the entirety of g. So my entirety of g is negative 10 times the square root of x. So what do I have? I have 3 square root of x's, and I'm adding negative 10 square root x's. If you're adding a negative, you are subtracting. So I'm subtracting 10 square root of x's. So I can physically see that I had 3 square root of x's, and I'm being asked to subtract 10 square root of x's. So I am counting the square root of x's. If I had 3 and I took away 10, I have negative 7 square root of x's. So my final function is negative 7 square root of x. After we found it, we are asked to then evaluate our new function when x is 4. So I have the f plus g of x function equaling this negative 7 square root of x. But I am now given an x to be 4, which means I need to replace these x's with the number 4 and evaluate. So my new f plus g function at 4 is going to be negative 7 times the square root of 4. These x's were replaced with the number 4 that I was told to evaluate at. So I have the f plus g at 4 function. This is now negative 7 times, what is the square root of 4? The square root of 4 is 2. So this is now negative 7 times 2, which meant the f plus g function at 4 gives me negative 7 times 2 is a negative 14. We just evaluated our function. Now let's go ahead and talk about domains. First, we need to figure out the domain of each individual function. So first, let's look at the domain of just f of x. Domain, it looks at all of the x values. So if I have 3 times the square root of x, we know when we graph the square root of x, square rooting graphs kind of look like this. That's the parent function. This is not moved up or moved down. It is just multiplied, which means it's stretching, which means this point stays right here. That means it never went below this 0 line, and it never went to the left of this 0 line. So we have our domain and our ranges all harping on this one point right here. We are interested in the x values because domains look at our x's. The last x value used is this x of 0. And I don't see it going any more this direction, which means that my domain is when x was always 0 or larger. So it's greater than or equal to 0. So let's go ahead and look at my domain of g of x. G of x is also a square root of x. This is also only vertically stretched. I see no adding or subtracting, which means it's not moving left or right, up or down, which meant it also goes through this same exact point, which means we also have a greater than or equal to 0 domain for this. So if f says only look at the positive x values, and g says only look at the positive values, then that meant that the new function f plus g of x also says, hey, only look at the positive values. What do they have in common? That is the domain for the next. So you are asking yourself, what did f of x and g of x have in common? They both say positive x values. So that meant the domain for our new function is also x is greater than or equal to 0. Let's go ahead and look at another problem. We are given f to be negative 1/2 times the third root of x, and we are given g to be 9/2 times the third root of x. And we are being asked to find the f plus g rule. If I'm being asked to find the f plus g of x rule, then I need to take my f and I need to add it to my g. So I need each one individually. So here is going to be my f rule, and I need to make sure that I add that to the full complete g rule. So what was my f rule? It was the negative 1/2 times the third root of x. My g rule was the 9/2 times the third root of x. So what do I have? I know that I have a negative 1/2 times the third root of x, and I'm being asked to add this entire 9/2 times the third root of x. So I visually see I had negative 1/2 of these third root x's, and I'm being asked to add 9/2 of these third root x's. So I am counting the third roots of x. I had a negative 1/2, and I'm adding 9/2. Negative 1/2 plus 9/2 is 8/2, but 8/2 can be simplified down to 4. So this is 4 times the third root of x. This is my new f plus g of x rule. Well, now we're being asked to evaluate that when x equals a 1,000. So my f plus g of x rule, when I am being asked to, I need a new parenthesis. When I am being asked to evaluate this x to be a negative 1,000. So I have f plus g at 1,000 equaling 4 times the third root of 1,000. All of these x's were replaced with the 1,000 I was asked to evaluate at. So my f plus g at 1,000 is going to equal, I have 4 times The third root of 1,000 is 10. So 4 times 10 is 40. So my f plus g at 1,000 gives me the answer of 40. Well, now we need to go ahead and we need to look at our domains. If I'm being asked to find the domain of the entire new function, I first need to actually look at the domain of each individual function. So the domain of f of x. This is a third root function. If you remember, the parent function of a third root function looks like this, where your domain is all real numbers and your range is all real numbers. If you're not adding or subtracting on the inside, or adding and subtracting the outside, nobody's moving up or down, left or right, which means this is still what my function looks like. So if my parent functions was all real numbers, then my f is also going to be all real numbers. So now let's go ahead and look at the domain of g of x. Again, g of x did not move left or right or up and down. So my g of x looks pretty close to my parent function. Since my parent function's domain was all real numbers, my g of x is all real numbers. So we found the domain for f and the domain for g. So what is the domain then of our new f plus g rule? You're asking yourself, what did these two have in common? He says I can use everybody. He says I can use everybody, which means the domain of my new function is also everybody. So he is all real numbers. This is our next problem. I would like you to please try this one for independent practice.